And this video here is expected value. Expected value is a really interesting thing. It's what you should expect to win or lose, or it doesn't have to be winning or losing, but that's normally where we take this to. So expected value is if it's winning and losing money, it's the money times the probability. So in the simplest form. Now obviously this is going to be a little bit trickier, but the probability here of something occurring, and then it's the money. And so like actuaries, people that work for insurance companies, etc., this is expected values, and hence how they figured out what the premium payments are. You know, premium is how much you pay for, say, life insurance and all that kind of stuff. They figure out these expected values, and so then they can figure out what they're going to charge you. Okay. So, but again, it's in the simplest form. It is the money times the probability, or whatever the significant thing that has, it's the value times probability. So it doesn't have to be money. So like, for instance, it could be extra credit points or whatever it is. So let's give it as a very simple example. We've got a dice. All right, we got a die, I should say. And if you roll a one, then you gain 2 points. It's plus 2 points extra. 2 points extra credit. If you roll a 2, you get nothing. All right, 0 points. If you roll a 3, you lose 2 points. If you roll a 4, you gain 1 point. A 5 gains you 6 points. But a 6, you lose 2 points. All right, so this is a kind of a game that you would have. So you're rolling a die. So maybe after our test, we want to gain some points, possibly, and you have this choice. It's risk reward. The question is, do you want to do it? Well, what's the expected value? So how much should you expect to gain? So we've got to figure out the probability, and it's going to be the summation of all of these that we have here. So you get, for rolling a 1, that's a 1 in 6 chance, you get 2 points. For a 2, that's a 1 in 6 chance, you get 0 points. For rolling a 3, you lose 2 points. So you have a 1 in 6 chance, but you lose 2 points. That's negative. A 4, still 1 in 6 probability, and you gain 1 point. And then finally, last two here, we've got 1 in 6, which is going to gain you 6 points. It's a lot. And then finally, the last one, you're going to lose 2. So there's going to be a -2 back here. You can't really see it, but -2. All right. So now you're going to type this into a calculator and find out what the end result is. If it's positive, you should expect a gain. All right. So that should be a gain. If I get negative, that means I'm going to lose points. All right. It's going to be a loss. All right. I'm going to type this in the calculator. So this has a value of 0.833. So if I add this all up, it's 0.833, repeating, assuming I typed this in the calculator correct. I think I did. So that means that every time you roll a die, you should expect to gain 0.833 points. So like now obviously you can't get 0.833 points, but let's say that I roll a die, 10 times. If I roll it 10 times, how many points should I expect to have? Because obviously it's not 10 points, 10 times. So 10 rolls. Oops, still not that. 10 rolls. All right. How much should I expect? Well, 10 times 0.833, that would be 8.3 points. So if I'm rolling 1 time, I don't know if I'd want to risk losing 2 points on a test. I don't know if I want that. There's 2 times it's going to happen. But if I'm going to roll 10 times, if I get to roll 10 times, then it's worth it. Because, I mean, shoot, you could hit jackpot and all that kind of stuff, but the likelihood is the larger the sample size, that the greater the chance that we'll gain points, right? And this is what I'm expecting to win. And if I got to do this 100 times, if I did it 100 times, then I'd expect to get 83 points. And that'd be quite a feat. So that would be the first example of expected value. Now, in order for a game to be considered fair, if a game is considered fair, then the probability, the expected value here is going to be about equal. It's about 0. It's about 0 is your result, okay? So if a game is quote-unquote fair, that means that both people have about the exact same probability. Honestly, in blackjack and in roulette and craps, they're pretty much quote-unquote fair because they're about the same. However, the casino wins because your human psychology and people stay and they end up losing and that kind of stuff because they might have a 51-49 advantage on those games. All right, let's do another example here. All right, so we're going to draw some cards out of a deck. We're going to draw, I should say, cards out of a deck. All right, so and you have to pause it and write these down. All right, so you're going to draw a single card out of a deck. If you get a heart, it's $5. If you get a spade, it's $10. If you get a jack of clubs, it's $20. If you get the ace of diamonds, it's $100. But it costs you every time you play. It costs $10 to play. So like for instance, you put $10 in, you get $5 back. So you actually really are technically losing some money. Let's make it, because let's make this a little bit more quote unquote fair. Let's make this $15 and let's make this the heart $15. We'll make it a spade is that, jack of clubs is that. Okay. All right. So the question is how much, or is this quote unquote fair? Let's figure out what the expected value is. So we got to figure out the probability. And when we do this whole thing, we're going to figure out the expected value. And then at the end, we'll subtract $10 because that's how much it costs to play each hand. All right. So that's the idea. So for a heart, there's 13 hearts out of the 52, or 25%. So it's 13 out of 52, and it's times 10 or $15. And then you've got the spade, which is 13 out of 52 times $10, because that's how much you're getting. The jack of clubs, there's only one jack of clubs, so 1 out of 52 times 20. And then there's one ace of diamonds, which you get $100 up, and times $100. And so we're going to multiply this whole thing into a calculator. And then since we're playing, and it costs us money, it costs us $10, we can figure it out that way. So let's type it in a calculator. So if I add this all up, it's $8.55 or 56 cents. That's what that is. And then if I subtract the $10, so again, I typed all this in my calculator, and I subtract the $10, that means I'm going to lose $1.44 is what I'm expected to gain there, which might make it interesting. Basically, in all honesty, there's only 25% of the cards you sort of get your money back. In these ones here, 25% you gain a little bit, 25% you just get your money back. They call that a push. There's only one card that gets you a $20, but there's that big one. And that's sort of like how lotteries work. The expected value in a lottery, I mean, it takes for it to get up to a certain, super high number, and then you get your expected value to be close to your ticket price. So, yeah, people keep on playing. All right, so our expected value, $1.44. So that means if I played this game 100 times, I should expect to lose $144. All right, lost. And that's in 100 games. Is what's going on there. So that's another example of an expected value. Again, the hard part might be just finding the probability, and then you multiply that. Let's do another one similar to this. So we'll say the queen of spades. Queen of spades is a win, $100. Okay. All right. The other queens that we have, that one, they're going to be a win of $50. The other face cards, that's a loss of $20. Okay. Aces, it's a win of $200. All the rest cards, all of the other cards, all right, all of the other cards, it's going to be a loss. So lose. Now I wrote this out nicely for you, but you got to be able to figure this out. So lose, let's say $10. Okay. I feel like the gamblers get the advantage here. The casino, I think, might lose money here. So, all right, so if you get the queen of spades, it's $100. So we got to figure out these probabilities. There's one queen of spades in the whole deck, so that's 100 times 1 out of 52. The other queens, you win $50. Well, there's 3 queens out of the 52. You see as an OR probability, hence why we have that. See, the aces win. I'm going to do the aces here. $200. There's 4 aces in the deck. And then the other face cards lose. All right, so how many other face cards? Well, there's... All right, got interrupted there. So the face cards that are not queens. So there's 12 face cards total. 4 of them are queens. All right, so that makes 8 face cards that are not. So you lose $20, so it's minus $20. And there's 8 of those cards. And then finally, of course, all the other cards. So how many other cards, this is where the work is taken into account. It's $10. How many other cards are there? 15, 16, so 36 other cards. Again, I just made this problem up. We'll see how close it is. See how fair it is. So we'll type this into our calculator. All right, so if I do this, I'm gonna get a negative number actually. So this means it's $1.34, you're gonna lose. So you're losing $1.34 is what or $1.35, I guess, if it's rounding. So if you played this game 100 times, you would expect to lose $135 in that. So it's I would say, quote unquote, fair, yes, because it's so close to zero, $1.35 on that. It may be in other standards, maybe not, quote unquote, fair, but the fact that the expected value is close to zero. All right, so this is expected value, and like one other application would be for life insurance. I'll write down a situation here for life insurance. All right, so let's say in the next year, all right, in this next year, in a year, the probability of a person getting in a car accident, we'll say, is 4%. Say 4%, okay? Which on average will cost the car insurance company on average $8,000, given and based on the car or whatever, okay? Now the question would be how much this car insurance company they're charging. And let's say that I said life insurance, I meant car insurance here. That's what I said. All right, car insurance. So it's car insurance, and of course, they are going to charge you a premium. So that's how much they charge you, a premium, and we'll say it's $540 for the year. This is a single person. Obviously, it's a 4%. This is not one of you guys because you guys have such a high probability of getting in an accident. So, all right, so how much does the car insurance company expect to make per customer, or in this situation? They're charging $540 for the year. Well, their cost here is $8,000 times 0.04. And so they're expected to pay out, given the scenario, $320. But if they're charging $540, then that means that they're expecting to make $220 per insurance premium. And of course, 220 times whatever, if they have 1,000 people, if they have 1 million people under the thing, they're making lots and lots of money. And that's how that works. And now some years, though, something happens, say a hurricane or whatever, and it might cost them more money. But this is maybe what they are projecting for this. So, all right. Good luck on our expected values worksheet.